Hello everyone, welcome to the CS Revelation. In this video, I'm going to walk you through the process of database development lifecycle, and that is going over the various phases that make up this SDLC, taking a closer look at what happens at each phase and what is the outcome of each one of these phases. Now, before investing in database development, it's important to understand the life cycle that's essential to this process and how it all works for your business. And the very first and arguably the most important aspect of the database development is the requirement analysis phase. This is essential for determining the framework and the requirements for the database being developed. It's also an important way to determine if the scope of the project fits your timeline and if it meets your budgetary needs. Usually, interviewing of both producers and users happen at this phase, and the outcome of it is the requirement specification. The next phase, which is the logical design, that's when we turn the requirement specification into an actual conceptual data model. It's also called the logical design, also called the ERD model, entity relationship diagram. And also normalization happens at this logical design, and that is to eliminate any database anomalies or inefficiencies. This logical design, which is the ERD model, is then going to be turned into an actual physical model, transforming it into relational tables. So we're going to start looking at tables that are interrelated. We're looking at tables related to other tables. And finally, the implementation phase. And at the implementation phase, that's when we're going to start seeing code. Well, that's when we start creating the tables, writing our queries, and so on. So let's take a look at this example that's going to help us understand this process. So at the requirement specification, you may get a description of the database that is written in English. This is a very basic example. Just we wanted to keep it simple so we'll understand this whole process. So the requirement specification here is that a professor teaches 0 or many classes, and a class is taught by one professor. A course may generate 0, 1, or many classes, and a class comes from one course. A class is held in one room, but a room has 0 or many classes. So this was the outcome of the requirement analysis phase, and that's basically after interviewing the users and the producers and gathering all this data, and we came up with this requirement specification. Now, our goal is really to turn this requirement specification into a logical design, and that is the second phase of the development life cycle. So to do so, the first thing really that needs to be highlighted here is the actual entities. We are going to be creating an ERD model, and an ERD model is composed of entities, right? And the best way really to locate entities is to highlight any noun that you could find. That's my shortcut, and it works 100% of the time. Just highlight all the nouns that you see. So in this case here, I have highlighted all the nouns in my requirement specification. So I see professor, there's course section, there is course, there's also room, and there is so course section. So we have a total of 4 nouns, and those are candidates for entities. So I took those nouns and I put them in boxes, right? Rectangle like this, and that is the symbol for an entity. So an entity is a rectangle shape that has a name and of course has other elements that we're going to see while working on this. So first, like I said, turning the requirement specification into an ERD starts by, first of all, finding the entities. And the entities is by highlighting all the nouns. Like we did here, we took those nouns and put them in rectangles. Next is to really find the relationships between these entities. And like I said, a shortcut is to find all nouns for entities. And finding relationships is just find all the verbs. So here I highlighted all the verbs in different colors. So teaches, taught, generate, comes, is held, and has. These are the verbs that I see in my requirement specification here. So let's see which ones are related to what entities, right? So a professor is an entity, teaches course section. So definitely we have a relationship between professor and course section, and that's why we draw a line that links the professor entity with the course section entity. And then we have a course may generate, so that's the other relationship, generate. So a course may generate 0 or many course sections. So here we have a course is the entity, and course section is the other entity that is related through this generate relationship. So course comes from course sections, and course section generates course, right? So actually the second part of this is that we highlighted comes, right? Comes from, and that is because we're saying course section comes from one course. So course section comes from, course section comes from one course. And a course generates course sections. And the last relationship is going to be between course section and room, and that is because in this sentence here, it says course section is held in one room. So here is the relationship of held in. So course section is held in room, and room has course sections. So here we have a relationship between course section and room. So step by step, we're shaping up the ERD model. So first we have decided on the entities and put them in the boxes, and then we found our relationships by highlighting these verbs and drawing a line that's going to link these relationships. Of course, you could describe the relationships by typing the name of this relationship by adding that verb, right? So teaches, that is the professor, teaches course sections, and course section is taught by professors. Now, the next thing, that is to find the cardinality symbols. It's just really, how can we describe this relationship even further, right? And to do so is really to look at the other parts that we haven't highlighted. So, for example, the purple part that is highlighted here, saying that professor teaches 0 or many course sections. So here we're talking about like, what is the maximum course section that this professor could teach, and what is the minimum as well? So this is the part where we say professor teaches course sections. So we're describing the maximum course section and also the minimum of course sections that a professor could teach. And it tells us here that it's 0 as the minimum and many as the maximum. So many is like the crow's feet. You can, draw that. And 0 is just the 0 symbol. So this is the cardinality symbols that describe 0 or many relationship. And the other side of the relationship is by looking at this. So course section is taught by one professor, right? Is taught by one professor. So actually here it's talking about the maximum and the minimum at the same time. So saying that the professor is taught by a maximum of one, course section is taught by a maximum of one professor, and a course section is taught by a minimum of one professor. And that's why we put the vertical line that is closest to the professor, that's symbolizing the max, which is 1, and the other one is symbolizing the minimum. So 1, 1, that is max and min. And of course, you would describe the rest of the relationships the same way. So course may generate 0 or many course sections. So that is generates. So it's many as the maximum and 0 as the minimum. And also here it says course section comes from one course. So comes from. So the course section comes from a maximum of 1 and a minimum of 1 course. Then the last relationship, here the course section is held in one room. Technically, the 1 here is talking about the maximum of one room and a minimum of one room. So a course section is held in a maximum of one room and a minimum of one room. We have the 1, 1 right here. Then we have a room has 0 or many courses. So that means a room has a maximum of many course sections and a minimum of 0 course sections. So it looks like our ERD model is coming to a complete picture because we have been adding all these symbols by interpreting this requirement specification. So that's how you really do create an ERD based on a requirement specification, is that you really need to take a look at all these different components one step at a time and then just assemble them. And the next step is really to add in some more information about these entities, and that is really called the attributes. We need to add attributes. Attributes here are the elements that make up entities. So, like for example, a professor has a professor's ID, has a professor's first name and a last name. That's the information about the professor that we want to keep track of. That's what we want to include in our database as in information about the professor. Same thing here for course. We have course ID, course description, room number, room capacity for room, and also we have other elements that describe the course section. Some of those elements are there by default, and some are generated based on relationships that we see here. So, for example, you see here course section, professor's ID. It says that it's a foreign key. FK means foreign key. And that is because we have a relationship between professor and course section. And a relationship, it has to be represented by sharing a column, right? So a column is going to be shared by the two related tables. So course section is related to professor. That means they must have a shared column. But who really gets the copy of that column, right? So who gives a copy of its column? When we say column here, I mean field, I mean attribute. I keep saying column because we're going to turn these attributes into columns. But let's say right now we're actually just saying attributes. So who gets the foreign key attribute, which is the copy of the primary key attribute? It's the one that is with the many side, right? So this is the relationship, and usually it has to be a one-to-many relationship. That means the maximum on this side is one, and the maximum here is many. So it's a one-to-many relationship. And the entity with the many side is the one that's going to get the foreign key, which is the copy of the primary key of the other entity. So in this case, course section has the many side, therefore is going to receive a copy of the primary key of professor, and that is professor's ID. But it's going to serve here as a reference. It is a reference to this professor's ID. So here it's going to be listed as a foreign key, and here it will be listed as a primary key. Same thing here, we have this relationship of generates, course generates. So course ID here is a primary key, and the many side is on the course section. So therefore, course section is going to get a course ID as a foreign key. And like you guessed it, because of this relationship, the many side is on the course section. Therefore, course section is going to receive a reference to room number, and that is why we have room number here as a foreign key. Okay, so there are some attributes that by default we know about the entities, and some attributes that will be generated based on the relationships. The third phase, that is to create the physical model. And that is to turn the logical model, which is the ERD model, into a physical model. And this is really the translation. It's that the entity becomes a table, and the attributes become columns or fields, and the relationship is going to be a shared column in both related tables. Like we saw here, is that this is professor's entity. It's going to be turned into an actual table. These attributes, professor's ID, professor first name and last name, will be turned into column names. And the relationships will be turned into a shared column like we saw here with the foreign keys. So this is what we mean by turning a logical model to physical model. So here's a professor entity is turned into a professor's table. So now we're not talking about attributes anymore. We're talking about columns. So professor's ID is a column, professor first name is a column, professor last name is a column. And of course, here you're going to also decide on the metadata, means deciding on the data types of data and restrictions and constraints of on data that's going to be stored in these fields, in these columns. So here number 5 means we're saying that professor's ID is going to be of type number. However, it has a restriction that it is a maximum of 5 digits. Okay, you can use any numeric data type, but this is just an example. And here we have professor first name. Varchar here means strings in other programming languages, or text. Because we're typing characters, we're saying that it's a maximum of 25 characters long, but it is of type text. Same thing here for last name. Then for course, also similarly, we have turned these attributes into columns, and we've decided on the data types, and room table as well. Now for course section, there's something that is very important to decide on, is really what is the primary key. So any table must have a primary key. And usually the primary key is the column or the field that's going to make every single row in this table unique, right? So it's like, for example, like social security numbers for, employees. No two employees that would have the same social security number. So all social security numbers must be unique. So if we base our primary key on social security numbers, then we can distinguish all these different employees, by just looking at their social security numbers. How to distinguish between them is just to say, okay, the employee that's related to this social security number is different from this employee that's related to this social security number. And in our case, it's course section. So really, course section ID by itself may not make everything unique. That is because we may have two sections of the same course running at the same during the same semester, and it's not really to guarantee uniqueness. So one other way to achieve this is to create what we call composite key. A composite key is just a combination of more than one column or one field. When you combine them, the combination of those two will always be unique. And once we start really looking at data, it will become more clear. Okay, so this is the final outcome of the physical model, which is really the entities turned into tables and deciding on the metadata. The next phase, which is the implementation phase, that's when we start typing code to turn these physical model entities or tables into actual database tables. And also, that's where we start adding data. So it's basically data definition. We're going to use data definition language to define the structure of this database. We're going to use data manipulation to manipulate the data that we have in this database. Also, we're going to use data query to retrieve data from this database. In addition to creating this database as well at the implementation phase, that's when you do the maintenance of your database. So, and the transaction control as well. So this is the process of development life cycle. And in the next section of this video, I'm going to walk you through the process of implementation. It means taking a look at the code that's going to turn this database idea into an actual physical database that exists. Okay, for the implementation part, I must first say that I'm using Oracle Apex Database Management System, but feel free to use any database management system that you prefer. I just want to say, first of all, that this is an online DBMS, which makes it easier to work with, and it's portable, so you don't have to install it on a local machine, and you're not dependent on a local machine. You simply create a workspace, and that is by going to apex.oracle.com, and you create your workspace, an online workspace, then you start developing databases on that workspace. I will leave the link in the description. In addition to all the code that we're going to use today for creating this database, you will also find that in the description. So let's get started. Now, the first question really to ask is, which one of these tables I should be created first? Well, that decision could be made by looking at your ERD model. The ERD model here decides or tells you what needs to be created last, what needs to be created first, and the order that you could follow to create these tables. One thing to put in mind is that the dependent on should be always created first, because if a table depends on another table, then the dependent on table must exist first before the dependee, right? So in this example here, take a look. The course section needs some information that it's going to refer to. So like, for example, professor's ID, course section needs a reference to an existing professor's ID, right? So it says, I have a reference to what should exist, right? So professor has to be created before course section. And based on this ERD, the ones that have foreign keys must be created before the ones that give the foreign keys. So in this case, you could create course, room, and professor in any order. However, course section must be created last because it needs a reference to existing data, and that is professor's ID from professor, course ID from course, and room number from room. So we're going to start by creating professor, room, course, and lastly, course section. Okay, so let's take a look at the metadata here. So the first table here is professor. So let's start by creating that. So simply create. So I must say also that it's not case sensitive, but I use caps to distinguish between code and not code. So it is not case sensitive. So create table, that is the command to start by, and then the table name. So you're going to say professor. So create table professor, you open parentheses. In the parentheses, you're going to list the column names. And in this case here, we have professor's ID. So professor, I'm actually going to put it in lowercase. So professor ID, and the data type is going to be number. And we have a limit of 5 digits, okay? And there's something else about this column here, is that it is a primary key. So how do I state it's a primary key? There are 3 ways, but we're going to use the easiest way is just to simply type primary key here. I'm going to type this in caps. So primary key. Okay, and then you put a comma there because you're saying here's another column. If there's no other columns, you shouldn't add a column. So a comma. Comma states or indicates that there should be a next column coming in. So P underscore, what is it? Name. And that is of type varchar. So varchar, and the limit for that is going to be 25. Comma, because we have one more column, and that is PL name. And that is also varchar with a max number of characters of 25. And we are not going to put any commas there because there are no other columns. So this is the code or the create table statement that is going to create our table professor. So I'm going to run, I'm hit run here. And notice it says table created. So I successfully created the table professor. Now, just know that this is just simply creating the table, which is just the structure, but there's no data there yet. It is just the table with the columns, but there's no data yet because we haven't added any data. And we're going to see how we're going to do that later. The next table is going to be course. So I'm going to say create table course. And table course has also a list of columns, and the first column is going to be course ID, for example. Course ID is of type varchar. The reason why I chose varchar for course ID because it could include numeric and characters, so non-numeric, and that's why I decided to use the varchar. And because this is a primary key, I'm actually not going to indicate that the same way. I'm actually going to show you a different way to state that this is a primary key. Just bear with me. The next column is going to be course description. Yeah, so course description, and it is varchar 200. So varchar 200. And comma, the next line is going to be my constraint, and that is saying primary key, right? In parentheses, I'm going to say, what's my primary key to this table? And that is a course ID. So by doing this, I just stated the primary key of my table. Okay, so let me highlight this and run it. And notice I says table created. So now I have 2 tables created. The third table is room. Let's create that. So create So create table room, and that is going to have 2 columns as well. The first column is going to be room number. So room number is going to be of type VARCHAR 4. So VARCHAR. There's VARCHAR or VARCHAR 2, by the way. It's just that VARCHAR kind of allows you a certain number of bits, and VARCHAR 2 gives you more bits. This is primary key. And I'm going to add the other column, and that is room capacity. And room capacity is number with maximum number of digits, 3. Means 3 digits allowed. Okay, so this is the room table. I'm going to highlight it and click run, and it says table created. So now I have a total of 3 tables created. By the way, you cannot create tables with the same name. So if I attempt to create course again, right, it should tell me that name is already used by an existing object. That is because I already created course. That means I have an existing table with the name course, so I cannot create another table with the same name. Okay, so table names are unique. The last table that we're going to create here is the course section. So create a table course section. So course underscore section. Do not use the dash, which is the minus sign, because it's going to render that as an error because it thinks that is a mathematical operator. So underscore will work. So course section has 4 columns. First one is CS ID. That stands for course section ID, and it is of type varchar 4. Varchar 4. Comma, we have a second column that is course ID. For this part, remember, course ID is a foreign key. Professor's ID is a foreign key, and room number is a foreign key. So it has to be the same way you've created them in the parent tables. You must use the same exact syntax. So professor ID, I'm just going to copy this, paste it here, because I need the same exact data type and the same name, because this is a reference, so it should be identical to its what it refers to. Okay, so course, that is comma. This is course ID also, and room number as well. So in total, we have 4 columns. That is course section ID, professor's ID, course ID, and room number. Now, remember we said that course ID is a foreign key, so we should indicate that that is a foreign key. How do we do that? There are various ways, but we're going to use the easiest way. So we're going to say references. So references, make sure you spell it right. So references, what table does it reference? It references the table that it comes from, which is course table. So it references course table, but what column in course table does it reference? It references course ID of the course table. And you're going to do the same thing for the other foreign keys. For professor's ID, you're going to say references. So again, I just missed that E. So references what table? It's professor table. And what column in professor does it reference? It is professor ID, right? And room number as well. So we're going to say references, references room table. Okay, so it references room table, but what column in room table? That is room number. And finally is the primary key. So in this case, we can't really put primary key in front of or after this professor ID or course ID. So we must use the second way, or there is a third way. But for this, we're going to say primary key. Because it is a composite key, we are going to use this method. So primary key, and in parentheses, you're going to list the columns that are considered to be your primary key, which is the composition of these two, course section ID and course ID. Of course, this is given, right? As a developer or as a database designer, this information is going to be given to you, and some of it will be decided by you, but some of it will be decided by your managers, your teammates, or maybe you. But before going into this, all that information is going to be generated. So the composite key, which is a primary key, that is CSID, means that I'm saying that it's CSID in combination with course ID will be my primary key for this table, right? So that's it really for course section, right? I listed all the columns, I listed the constraints, which is the foreign key constraints, and also I listed the primary key constraint. I hit run, and it says table created. So now in total, I have 4 tables in my database. I've created 4 tables. Really to, make sure that you've created these tables, you could simply type, for example, describe. This is a command to find out if your table is there. So describe professor, let's see if this works. And notice that what you get here, description of your table professor. So this is the table, and this is the data about the data, right? So this is the table name, professor. These are the columns, PID, PF name, PL name. This is the data type, number, VARCHAR2, VARCHAR2. The length here is for the characters, VARCHARs, 2525, and the precision is for the numbers, so that's 5 digits. And of course, the primary key here is the one professor ID, right? So you could do also describe the other tables. So you could say describe course. That is just to make sure that everything is, according to plan, and that you've created your tables and they already exist. So this also gives you the description of the course table. Let's describe as well room, just to make sure that room is there. So describe room, and it's also there. Let's describe the course section. So describe course section. All right, so let's run it. In Oracle Apex, if you want to run some section of a code, you just highlight it and then hit the run button. So our primary key, notice that's 1, 2, right? It means it's these 2 columns together. And the length is 4 here, 5 here, 4 here. And and of course for what else? Yeah, so we have everything we need for our course section table. All right, so the creating the part of the creation of the tables is done, which means we've seen how to use data definition to define the structure of these tables. However, data definition is not just about creating tables. It's also about altering the structure of these tables. So you can change the names of these tables. You can rename columns. You can add columns. You can remove columns. You can change data types of columns and so on. Feel free to take a look at some of the videos that I posted. As a matter of fact, the link is below in the description on how to use the alter table command. Okay, and the next part is really to populate these tables with data. So we're going to take a look at how to add data into these tables. Okay, so to insert data into these tables, we use the following code. So we're going to say insert into, and then of course the table name. Let me just say also that the same order you created the tables is also the order you're going to follow when inserting data. So the tables that you created last, those are the tables that you'll insert data into them last. That is because some of the data that you're going to be inserting into those tables is just a reference that a data that must exist first. Okay, so we're going to follow the same order that we followed when creating these tables in inserting this data. So insert into professor table. So we're going to insert. Now there are two ways to do this. It's either that you're going to put the column names in parentheses. So for example, we say professor's ID, comma, it's going to be professor F name, and then comma, professor L name, right? So here you have the columns, the order of the columns, and of course you're going to add values. And that is basically the values that you're going to be inserting. I'm going to align it with this just so you see what column is aligned with what value. So we're saying here that we are inserting values, a value for each one of these columns. So it's going to be, for example, professor's ID, and it is a number. So I'm going to say 111. That's 5 digits. And then comma, the next value is the professor's first name. So I'm going to say Tim and the last name. So varchar has to be in single quotation marks. Okay, so varchar, which is text, has to be enclosed in quotation marks. Numeric, you don't put any quotation marks. And the last name is also varchar, so I'm going to say Tim Small, for example, and a semicolon here. So this is just one statement, one insert statement that is going to insert one record, one row into the professor's table. So highlight it and just simply hit the run button, and it should say one row inserted. So this is one way to do this. Actually, if you're sure about the order of these columns when inserting, you don't have to list the column names. You could simply say insert into professor, and then you put values, and then in within the parentheses, you're going to put the values. Of course, remembering that each one of these values is going to go with the appropriate column in that order. Now, look, I'm going to attempt to insert this, and notice what's going to happen. I'm actually going to get an error saying unique constraint violated. And the reason for that is because I'm attempting to insert another record that violates a constraint in the professor's table. And that constraint is the primary key constraint. So I said that the professor's ID is a primary key, which means that that column should only have unique values. So if I've set 1111 into as my professor's ID for Tim Small, then I should use a different ID for another professor. So I'm going to say Tom and say Smith. Right. So here I have a second row that I'm going to insert into professor's table. So I've inserted 2 rows. I can insert as many as I want as long as I maintain the constraint, which is the primary key constraint that has to be unique. Names don't have to be unique, first name and last name, because I haven't set a restriction on them. And they could be null as well. But this value here cannot be null, and it has to be unique. That is for the professor's ID. Now, if I want to take a look at the data in my professor's table, I could simply run a select statement, which is called data query. So select, I'm going to star from professor. So a select statement selects a list of columns from a specific table. So the star here means list all the columns and from table name. So we're selecting whatever columns from the table name. So here, these are all the columns, professor's ID, professor's first name, professor's last name, and these are the rows that I just inserted. That is Tom and Tim. If I was to only select the first names, I could simply, list the columns that I want here. So I'm going to say professor underscore first name. So this is going to only show the data for that column, right? You see here we got Tim and Tom, but we didn't get the rest of the columns. And that's because this part decides on what columns to show, and this part decides on what table are we getting this data from. You can also get data from multiple tables at the same time, and I will leave a link below in the description to multiple table queries, and that is joining multiple tables and using subqueries. So take a look at that video. It's actually very helpful to understand how we can data query multiple tables at the same time. Okay, so let's take a look at how we can insert data into the course section, for example, or the course table. So we're going to say insert as well, insert into course, the course table. That's the table name. And I'm going to do values. The values are 2. It's composed of 2 elements. So this is the course table. It's composed of a course ID and a course description. So for example, because it is varchar, the course ID, I'm going to include it in quotes. So maybe like I'm going to say C 123, right? I cannot go beyond 5 characters. That is because the restriction is that it is a maximum of 5 characters. And then the second column is going to be the course description. Here I can go up to 200 characters. So I could basically say this is, so computer science introduction, right? So for example, that's just a description. And it's in quotation marks. That is because it is varchar. So I'm going to highlight it and run it, and there you go, one row inserted. I can insert as many as I want, so I'm going to just simply copy this and paste it, let's say 4 times. This has already been inserted, so these are the new ones. So this is C123. I'm going to make this C124. This is C125. Notice I'm making these different and unique. That is because the primary key of the course table is the course ID. And the part here where it says course information, the description, I can actually leave that as is, and it will insert it. But I don't want to do that because I want to have some data that makes sense. So this is going to be, for example, maybe I can make this advanced. Maybe this is, this course is going to be Java programming. And this is going to be, for example, SQL Database. If I was to insert all of these together all at once, the Apex database management system is not going to allow you to do so. It's going to say command not, properly ended. In SQLite, I actually tried this and it did work. But here, to overcome this obstacle, is to turn this into an SQL block. That's by enclosing this in begin and end block, right? So you say begin, end, right? So you basically making this one SQL block. So when you highlight it now, it will actually run it as just one statement. It's going to say statement processed. And that means it inserted all these rows all at once. I can find out if that is that took place. So I can say select star from the table name here is course, right? So let's highlight this and let's run it. Notice I get what I just inserted. These are the 5 rows that I inserted into the course table. So I have course IDs that are unique and course description. I'm going to attempt to insert another course ID with the same ID that is a duplicate. So C127 already exists. So I'm going to attempt to insert that. So it should say constraint violated, but in this case, it says command. Oh, that is because I haven't highlighted the right parts. So I'm going to run it again. Now this is the right error message. It says unique constraint is violated, right? It actually tells me that the constraint that's violated is about the uniqueness of one of these columns. And I know that I set this to be my primary key, so it should be unique. Therefore, this is not going to be allowed. That is just to showcase for you what it means to have a primary key. Let's also insert a couple of rooms, and then we'll head to core section because that's the tricky part. So let's insert into room, and then we're going to insert 2 rooms. The first room is going to be, let's say R. So this is varchar, so it has to be in quotes. So let's say R 123. So it's room 123, and the capacity, which is of 3 digits. So I can make that 100 students in this room. And I can insert another room. Let's actually insert 4 rooms because we have the copy and paste power here, so we can actually do that. The next room is going to be, for example, R222, maybe room R333, maybe room R444, And let's have the capacity here to be, for example, 25 students. This one's going to be, let's say 125, and this is 100, right? And let's, we already inserted, we didn't, we have it. Okay, so begin end, that is just to turn this into an SQL block, and I can run all of these together. Okay, so when I run that, it says statement process. Let's find out if the data is there. So I'm going to say select star from room. Okay, and let's run this, and there you go. It says room number, room capacity, and we have 4 rooms inserted, 4 records. Okay, so inserting data into course section, this is the trickiest part. Notice that this is the order of the columns. So if you take a look at the course section here, this is the order of the columns. So let's simply remember that the first value is for course ID, PID, co-ID, and our number. Okay, so I'm going to do insert into. So insert into course section, and then values. Okay, so the order of the columns first, we have course section ID. So course section ID is a VARCHAR 4, so I could basically say CS 11, course section 11. Then comma, what comes next is the professor's ID that's going to be teaching this course section. It must be a professor that already exists, that I have created already. I only created 2 professors, that is Tim Small and Tom Smith. So Tim Small's ID is this. So when I put the ID here, I'm basically saying that this course section is going to be taught by this professor with this ID. And if I want to know more about this professor, I take that ID and I go to the professor's table and I find out that his name is Tim Small. The next column is going to be the course ID, which basically saying, okay, what course that this course section is generated by, right? This course section is generated by from this course ID. So if it is this computer science introduction, then I use this ID, right? So I'm basically here saying that CS11 is a section of C124, and it's taught by this professor with this ID. And the last is going to be the room number. So the room number, I could choose any of these rooms that already exist because this is a reference to existing data. It's a foreign key. So I'm going to use R33. That is because that's, I know, for example, that this is a section that is going to include about 100 students, or maybe 111 or 125 students. Therefore, this is the appropriate room. So I can insert now this, 1 row inserted. Let's insert, let's say, 4 sections in total. So that means 3 more. Now, just remember that the data that is listed for the columns that are foreign keys must be data that already exists. So I can have, for example, this professor teaching another section, let's say section 12, CS12, which is a section of the same course, which is 124, and it's also taught in the same room. Actually, I could do that. Notice that the primary key of course section is really the combination of these two, right? So CS11 and 111, CS12 and 111, that's unique. It's not the same, right? So you have a difference here. The combination is unique. I'm going to make this 13, and I'm going to make it taught by this professor, which is Tom. And 114 is another section, and it's taught by also Tom. And it is a section, the first one is a section of course 125, and this is a section of 126, right? Actually, I'm going to make this 127. And this is going to be taught in room 222, and this is room, for example, 123. I cannot, let's say, for example, list a room number that doesn't exist. Let's attempt to do that. So let's say R555. That's a room that doesn't exist. We haven't inserted that room. If I try to insert this, let's make this a section 7, just so we don't have the problem of the primary key unique violation. So, wait, that's not the one. This is the one. So if I want to insert this, notice what happens. It says integrity constraint violated, parent key not found. It really, what's it referring to is this. It says this is the child key that is the foreign key that references a parent key, but the parent key doesn't exist. You're saying it's room 555, but I went into the room table, I didn't find that reference, I didn't find that room number, right? So you really need to use a room number that is already existing in our database. So R444 exists already, so I'm going to insert these now. I'm going to put begin and end here. So in total, I'm going to have probably 6 course sections. So let's find out all the course sections that we have in the course table, all the records. So I'm going to say select star from course section. And notice that we're going to get a list of records. In total, here we have 5. I mean, here it shows, 4, I mean, 5, I mean, what is it? 4 insert statements, but one of the insert statements we altered and then, ran it twice. So here we have, we said that CSID in combination with PID is primary key. Therefore, all these combinations must be unique. So notice CS171111 is not the same as CS121111. And also CS131112 is not the same as CS14112, right? So in other words, all these combinations are unique, therefore that's my primary key, and its constraint is followed and it's not violated. Now that you created the tables and you inserted data into them, the final part is using the database. Using the database means we're going to apply some data query. Data query language, that means select statements. That means we're going to retrieve data. So suppose that you want to know, for example, the total number of professors that you have, or maybe the number of course sections, or for example, you want to know the rooms that have, how many rooms you have that have capacity greater than 100, or how many course sections are generated for a specific course, and so on, right? So suppose that we want to know, for example, how many professors do we have in our college, for example, in this database. So we could do select. So we're going to do select. And then we're going to use one of these functions. By the way, if you want to know more about SQL functions, I have a video below in the description that walks you through all the different SQL functions. So count is going to give you a count of rows from that professor table, of course, where a specific condition is met, right? You don't want to count, so you want to count, there's no condition here because really we just want all the professors, not specific type of professor, but we want all the professors. So if I run this, I will get 2. I only have 2 professors, that's Tim and Tom. And if I want to count, say I want to find out how many rooms, so if I want to find out how many rooms do we have, so I could basically do a count of rooms. So a count star means count all from room table, right? So this is going to count how many rooms in the room table. So so count, not count. So count the number of rooms. I have 4 rooms, and if I want to know, count only the rooms that have a capacity greater than 100, then I need to add a where clause. So I'm going to say where, what is it, our capacity? Yes, it's our capacity is greater than or equal to 100. So here I'm adding a condition. So only the ones that satisfy a condition, I'm going to count them. So now I should get 3, yes, not 4, because these are the rooms that I have in my table, and one of them is below 100. The rest are 100 or above. So in total, I have 3 that satisfy this condition. If I want strictly greater than 100, then it should be just 1. And that is 1 room. You can also, for example, find out the number of course sections for each course. So you can simply select what is that you want. You want the course, let's say course number, right? So I want the course ID, and I want a count of course sections, right? I want a count of CSID, right? So I want to count of course IDs. And that is from what table? So these 2 columns exist in course section. So I could simply use just one table, that is course section. But this is a count per course ID. So this is a grouped total. So therefore, I'm going to use this group by. By the way, there's a link also below in the description that tells you more about the group by and the group by command. Okay, so group by what? We're grouping by the course ID, which means that we're getting a total per group ID. So it's a group total per group ID, course ID. So each course ID is going to have a number of course sections. So we have this course ID has 1 section. Course 124 has 3 sections. Okay, so that's that. Now, of course, you could do a lot with this, and you can involve multiple tables as well in your select statements. I also have a video that shows you how to involve multiple tables in one select statement. So how you join these tables and then query them together, or you could use subqueries. I'm going to give you one taste of that, but you can use the link below in the description to learn more about joining tables and multiple table queries. So suppose that what we want to know is find the room numbers where, let's say, Professor Tim Small is teaching, right? So here, just put in mind that when you have an SQL statement or select statement to generate, you really don't have access to the data. You don't see the data. You should just know the structure of your database, means how does the database look like in terms of column names and table names, and work with the data that's given in the question here. So what's given here? We want the room number. Therefore, we're going to get the data from room table. Room number is only in well, it is in room table, right? Yeah, so room number is in room table as well as in course section. So in this case, let's just say course section. So we can get that from course section. And in addition, that we want the Professor Tim Small, right? The ones that Tim Small is teaching at. So Tim Small is a professor name, and professor name is in the professor table. So therefore, I need data from the professor table. So you notice that I, answered the from part first, because even Oracle, when it executes a select statement, it actually starts with the from part. It means locate the table where you get the data from, and then select. I need also a where clause. Now, because I'm using 2 tables, I need to join the 2 tables. So it is the professor and the course section. Professor and course section will be joined based on their relationship. And the relationship is based on the shared column, and that is the professor's ID. So therefore, I must say that I only want the rows that satisfy this condition, which is that course section dot professor ID must equal to the professor dot professor ID, right? So I'm basically saying only give me the rows that have professor ID from course section equal to professor ID from the professor table. And also, and one more condition is that the professor name, like it says here, is Tim Small. So I only needed this condition is to join the 2 tables, but the next condition is really to filter out the results. I really want the first name. Wait, I need to mention the table. So it's going to be the professor dot, let's say, first name, which is P first name, must equal to, or you can use the like also operator, is like what? It's like Tim. And the professor dot last name, so the last name is also like small, right? So this is here, this is putting a restriction on what rows we want to keep. We only keep the ones that have a professor first name Tim and a professor last name small. But what do I want to get here is the room numbers. And where do I get that? Is from course section. And so I'm going to say course section dot room number. Okay, so let's find out what this query is going to give. It's given us no data found. Why is that? Hold on. So Tim Small. Okay, so this is Tim Small. And we want course section to be, okay. So let's see. So this gave us 3 room numbers. One of them, of course, is redundant because Tim Small is actually teaching in that room twice. But if I want to make only list it once, I could basically put this command called distinct, which is going to just keep the distinct value. So here, room 444 and room 333, these are the numbers where Tim Small is teaching. And if I was to find out, take a look. So Tim Small, who's the professor with ID 111, let's find out the courses he's teaching. So he's teaching this course section, and that is in room 33, and also teaching this course section that is room 44, and that's exactly what we got here. So means we got the correct results. Now, I'm going to stop here because I have another video that actually walks you through select statement and, multiple table queries. But this was just, gives you a taste or a flavor of the complete life cycle, development life cycle of a database, from requirement specification to logical design to physical design and to the final phase, which is implementation. So really, database development goes through various phases, and you must master each phase, and you can't really skip phases. And sometimes you spend more time at the planning phase because it will cost you less to change the requirement specification at that phase, because it's all about documentation and writing, what you think your database is going to have in terms of restrictions and how the database is going to look like and what does it include and so on. It's all about documentation. So it's easy and it's cheaper to make changes or to make a small tweak to your project scope at the planning phase rather than during the implementation phase. So if you already spend time and money and efforts and you've come up with this database and it is an actual database that exists, making changes to it is just going to be very costly. Therefore, going through all these different phases is the best and most efficient way into successful database development. So I hope this video has given you a taste of that, and I hope that you've learned the complete process and the development lifecycle of database. And I'll see you in the next one. Peace.